Hello class, welcome to this video on 6.7 review. So let's go ahead and get started. So if I look at first question for the problem set number 1, it says two planes take off from the same airstrip. The first plane flies west for 150 miles and then flies 30 degrees south of west for 220 miles. So let's do that one. Okay, so let's say we start here, and it says we're flying west 150 miles. And then flies 30 degrees south of west. So this is west, and we're going 30 degrees south of west. So this way for 220 miles. Okay. All right, and then it's then flies. Says the second plane. So here's the first triangle for the first plane. So this is plane number 1. Now the second plane flies east for 220 miles. Then flies X degrees south of east for 150 miles. Okay, so we got, this is east, and we're going some kind of value, X, we don't know what it is, south of east. So like that for 150 miles. All right, and then here's the triangle for that. So this is the second plane. So which plane is farther from the airstrip? And it says X is less than 30. So it says if X is less than 30, which plane is farther from the airstrip after the second leg? So is 1 or 2 bigger, in other words? Okay, well, first off, we know that this leg is congruent to this one, and this one is congruent to this one right here. Okay, so in other words, we're looking at these angles right here, right? So let's look at this angle. Well, to get this angle, we know that this angle is 150, because if this is 30, this is 180 minus 30. Okay, for that angle. Now, if X is smaller than 30, like let's say X was 20, then 180 minus 20 would be 160. So notice that as X becomes smaller than 30, that this angle right here becomes greater than 150. All right, so like 160 or 170. So the smaller X is on the right side, the bigger it is on the left side, right? And so we can see that this angle right here is bigger. So that means that the opposite angle, which is this 2 leg, this side that I labeled 2, has to be greater. So that means plane 2 is farther away from the airstrip, okay? Okay, so since X is less than 30, that means that 180 minus X has to be greater than 150. And since, so if we saw, and since the angle, and since this angle is greater, by the Henge theorem, the plane farther from the airstrip is plane number 2. Okay, so hopefully that made sense. This angle is bigger, and so this side has to be bigger, so it's farther away. Number 2, Jen and Ari start hiking from the same point. So they start hiking from the same point, and it says Jen hikes 5 miles east, 4.5 miles east. No, yeah, it says 5 miles east. And then she hikes 4.5 miles, 30 degrees south of east. So this is east, 30 degrees south of east, so that's 4.5 miles. And so this distance right here is for Ari. Okay, so this is 4.5 miles, and this is Ari, and then it says, for Jen, I'm sorry. So this is for Jen. Now Ari hikes 5 miles west, so like here. So these are the same distance, and then 4.5 miles, 15 degrees north of west. So this is west. She's going 15 degrees north. So that's 4.5 miles. So this is the same distance as this here. Okay, and then this is the 5 miles here. So who is closer to the starting point? So, all right, so if this is 15 degrees, then this right here, this is Ari right here. 180 minus 15 is 165. Okay, so that's 65 degrees. And this angle right here is 180 minus 30, right? So which is 150 degrees. So, so since 150 is less than 165, that means Jen has to be closer. Okay, so since 150 degrees is less than 165 degrees, Jen is closer to the starting point. Okay, by the Hinge theorem. All right. Okay, so hopefully that made sense. So now let's look at problem set number 2. All right, so we want to write a 2-column proof. Okay, so first off, number 1 is not a given. Number 1 is just the angle SXT and RXT are supplementary. So that's this angle and then this angle, right? Okay, so they're supplementary because that's a linear pair. This is the definition of a linear pair. Okay, because this is a linear pair, that and that, okay? So linear pairs are supplementary. And because they're supplementary, that means that the two angles must add up to 180, right? Oops, I need to put a plus sign here because they add up to 180. By definition of supplementary. Now, if we know angle SXT is 97 because that is given, right? They told us that, so this is a given. And so then what we can do is we can substitute that into here and plug that in there. So that's a substitution, right? We replaced that with 97. So substitution. And then, okay, so then what we're going to do is we're going to subtract 97 on both sides, and that'll get rid of that, right? So that's called subtraction property. So 180 minus 97, that's 83 degrees. And we know that 97 is bigger than 83, right? So we know that this is 83. We know that Rx is equal to XX because that's been given, okay? Because they told us that. And we know that this is equal to itself by reflexive property. I'm just going to mark that right there. And we can clearly see that SXT is bigger than RXT. We can see that, right? Because 97 is bigger than 83. So we can make a substitution. Because 97 is equal to SXT and 83 is equal to RXT. And we know Rx equals XS because that was given. And then it says Tx is equal to Tx because that's reflexive. That's what we had talked about earlier. Remember, we need these to be the same so that we can use Hinge theorem. And so now we can go ahead and say, all right, well, this is bigger, so that means this side has to be bigger, right? This side has to be bigger than the other side. In other words, ST has to be bigger than RT. Right, we always end with what we're trying to prove, and that's by the Hinge theorem. Okay, and that's the end of our proof. All right, let's look at the next one. All right, so looks like they wrote down the given statements. This all comes from here, right? So the reason is that it's been given. Okay, now they said that K is the midpoint, right? So this is the midpoint, which means that QK has to be equal to QS. And that's by definition of midpoint, right? Because that's what it means to be the midpoint. All right, they also tell us that RL is congruent to RJ. That's a given. So RL is congruent to RJ. And they say that LK is congruent to JK. LK is congruent to JK. All right. And they also said that SKL is bigger than KQL. So they're saying that this angle is bigger, larger. This angle is smaller. Or did I get that? I think I might have reversed it. QKJ is smaller. And this one's bigger. This one's larger. Well, if this angle is larger, then that means this angle has to be, or that side has to be bigger, okay? So that's just something to keep in mind. Yeah, so that means this side has to be larger. And that is larger than this one. And that is by hinge theorem. Okay. So now that we have the hinge theorem, we can say, okay, RL equals RJ. How do we know that? Well, because RL is equal to RJ because it's congruent, so that means it must be equal, right? So that is by definition of congruent. Congruent segments. All right, now we got SL plus RL is greater than QJ plus RL. Where do we get that? Well, we got that from here. And what we can say is, okay, SL, we took this statement and we added RL to both sides, right? That's what we did. We did plus RL, we did plus RL. So this is called the addition property. We're taking that and we're adding the same thing to both sides. All right, so we got addition property of inequality. And notice here we got replaced that with that. That's because of step 4. And so that's a substitution. All right, so now RS is equal to SL plus RL. Okay, so we got RS is equal to SL plus RL. That is a SAP because we're adding 2 segments to make a bigger segment. So that's a segment addition property or postulate. All right, and then we're going to end what we're trying to prove, right? So we're going to end what we're trying to prove. We always end with the prove statement, okay? And why is that true? Okay, so let me get rid of this red stuff here. So we get step 8 from step 6, right? We know that this here is equal to RS, right? So we're going to replace that. And we know this is equal to QR, so we replace that. So that's another substitution. All right, and so that ends the proof. All right, so there's problem set 2. Now let's do problem set number 3. Find the range of possible values of x. All right, so we're going to use the hinge theorem here. This angle is bigger than this one. That means that if I go to the opposite, this has to be bigger than that. Okay, so we know that 4x minus 10 has to be bigger than 40. All right, so let's do that. But if you think about it, since we're talking about the sides here, right? What's the smallest that this side can be? Well, the smallest that side can be is 0, right? Because no triangle can have a side length of 0, right? Because we're talking about the sides here. So it's got to be greater than 40, or it's got to be Okay, so yeah, so this has to be bigger than 40, but you know, also it can't. The minimum it has to be is 0, but that's not really That's not really something we have to impose, because if it's bigger than 40, that means it's already bigger than 0, right? So really, there's nothing else that we can impose on this other than being bigger than 40. Okay, so we can actually we don't have to impose anything else on this. We can just say, okay, it could be greater than 40, and there really is no limit to how big this side can be. So it could be really big. All right, so we're going to add 10 on both sides. We're going to divide by 4. We get x is greater than, so 50 divided by 4, that's the same thing as divide by 2. So it's 25 over 2. That's the same thing as 12 and a half, right? So 12, yeah, so 12 and a half. But that's good. So x is greater than 25 over 2. Now this one, here we're looking at the angles this time, so we can see that 36 is bigger than 30, and therefore 33 is bigger than 3x minus 3. So in other words, 3x minus 3 is smaller than 33. So we got 3x minus 3 is smaller than 33. But how small can 3x minus 3 be? Well, the smallest that it could be is 0, right? It can't even be 0. It has to be 0.0, you know, just above 0. So it has to be greater than 0, because it can't be too small, right? And those are my two restrictions. So we're going to add 3 to both sides, or all 3 sides here. We get 3 is less than 3x is less than 36. We're going to divide by 3 on all 3 sides. We get 1 is less than x is less than 12. So x is between 1 and 12. So x could be 11, 10, 9, right? But it can't be anything else. It can't be 1 or 12 or anything else other than those. All right, so we got problem set number 4. We got one more set of problems for proofs. So this problem set is really made for the converse of the hinge theorem. So we're going to prove using that. All right, so we got these, or well, actually, we got these two statements right here, right? So that's a given, because they gave it to us. So we're going to put given for that reason, and let's mark that on our diagram. So XU is congruent to VW. We also know that XU is parallel to VW, because it says that there. We also know that VW is greater than XW. And so that's another given. So let's do that. Let's fill that up. VW, let me just rewrite that. Okay, good. So that's a given. All right, so let's go through the steps one by one. So number 2, angle UXV, this angle right here, is congruent to XVW, congruent to angle XVW. So why are those two angles congruent? Well, if you recall, these are this is parallel lines and a transversal, right? So that's the sandwich model. So notice that those two angles are alternate interior angles. So those are congruent, as well as XUW is congruent to UW. Let's see, X. I got the wrong ones. XUW, this one right here, is congruent to this one. VZ, I'm looking at this one. Okay, yeah, UWV, sorry. All right, and those are alternate interior angles. So alternate interior angles theorem. Okay, so now notice that we got an angle, a side, and an angle. So these two triangles are congruent by ASA, right? So we got angle, side, angle, congruence. All right, so now that we got those angles, those triangles are congruent, well, then now we can say that XZ is congruent to VZ. So we can say, okay, now this here has to be congruent to this, VZ. And that is known as CPCTC. CPCTC states that if I know the two triangles are congruent, then the corresponding parts must be congruent, okay? So that's known as CPCTC. All right, so now that we know that, let's go to the reflexive property, step 5. Which one is reflexive? Well, what do the two triangles share, or what is shared among these? Okay, so now what we need to do is we want to focus on these two triangles, this one and this one. And so we want to focus on those because that's going to help us prove that's going to ultimately help us prove what we want to prove. Okay, so we notice that this side shares amongst those triangles, right? And that shared side, we're going to use that for reflexive property. So we can say ZW is congruent to ZW. That's what I'm going to do. Let me delete those lines there. Okay, so ZW is congruent to ZW by reflexive. So then this side, it becomes 1, 2, 3. And we want to use, so now we know that this side is larger because they told us that than this side. And therefore, this angle right here, has to be bigger than this angle right here, okay? And that's the converse of the hinge theorem. So we got the VZW, and then we got XZW is greater than XZW. Now to go from 7 to 8, okay, and now VZW and XZU, what are those? So VZW, VZW, yeah, so it's this angle, and XZU. So notice that those are vertical angles because they form the X, right? So this is true by vertical angles theorem. And if they're congruent, that means they must be equal by a definition of congruence. All right, remember now we can do the proof statement that goes last. Okay, so this is greater. So according to the proof statement, XZU is greater. How do we get that? What's the reason for that? Well, this is why we have step 9. So what we do is we replace this with XZU, and then we replace this with VZU. And notice that VZU is the same thing as UZV, okay? So it doesn't matter, it's just reversed, okay? So this is a substitution, in other words, okay? So substitution, and that's how we get that, right? And that's the end of the proof. So this one was a pretty complex one. So if you can know how to do something like this, then I would say you're pretty good as far as like doing well with proofs. All right, so number 2. AF is congruent to DJ, FC is congruent to JB, AB is greater than DC. That's all getting given to us. Okay, so let me mark this out. So we got AF is congruent to DJ. FC is congruent to JB. And we get AB is greater than DC. So so this right here from A to B is larger, and DC, oh, AB, sorry, I did it from AC. So this is larger, this is smaller. Okay, so that's all given to us. Now BC is congruent to BC. Notice that these two triangles that you see, right? This triangle and this triangle, they share BC, right? So we can say BC is congruent to itself by reflexive property. So we're gonna say that 1, 2, 3. So it's congruent to itself by reflexive property of congruence. All right, and then if it's congruent, then it must be equal, right? By definition of congruent segments. All right, and then notice that for for the number 4, it says AB plus BC, so that's this plus this equals AC. That's a segment addition postulate because you're taking two segments and putting them together, right? So that's classic SAP, segment addition postulate or property. Okay, and now it says AB plus BC is bigger than DC plus BC. So how do we get that? Well, what we do is we take this statement right here. If AB is bigger than DC, then what we can do is we could just add BC to both sides, right? And that's how we do that. So that's to get that, we just use addition property. So in this case, addition property of inequality. All right, and then to get step 6, notice that we replace, for step 6, we replace this with AC, and we replace this with DB. So that's a substitution property. All right, and then now we know that AC is bigger than DB. Okay, so we know that this is larger than that, and because AC is larger, that means that this angle is bigger than that one, right? The one the opposite. And that is essentially, that is what we were trying to prove, that AFC angle is bigger than the DJB angle. And that's what we were trying to prove. And that is the converse of the hinge theorem. All right, and that is the end of the proof. All right, guys, that's going to do it for the video. Hope you learned something, and as usual, I'll see you in the next one.